In this video, I'm going to discuss how to find standard normal critical values. So first, we need to understand what is a critical value. What is a critical value? Right. So a critical value is a number that separates the sample statistics that are likely to occur from those that are unlikely to occur. So in general, that's what a critical value is. So for example, say I had the distribution of x bar. Okay, so say this is the distribution of x bar of the sample mean. Okay, so a critical value would be the cutoff. These would be likely values of x bar, and these would be unlikely values of x bar. And this cutoff, these two cutoffs in this situation, would be the critical values, the values at which, these are unlikely and these are likely. Okay, all right. Well, actually, we're going to be talking about standard normal critical values in this video. So instead of the distribution of x bar, in this video, we're going to be focusing on the distribution of z. Okay, distribution of z. And our critical values then will be two critical values. The notation for them is negative z alpha divided by 2 and z alpha divided by 2. All right, what's going on with this notation? Remember, 0 is in the middle, so these are the same number, okay? So it's symmetric distribution with 0 in the middle. Alpha divided by 2 is the area that is in this tail, okay? And the area that's in the middle is 1 minus alpha. All right, so the positive side of the critical values. So this critical line that right here, this is what we call the standard normal critical value. Okay, so this is the standard normal critical value that we're going to practice how to find these guys. All right, so we use these in creating confidence intervals. So it's really important that we know how to calculate this, the standard normal critical value, so that we're able to calculate our confidence interval in the next video. All right, so let's do some practice where we have to find the critical values. So let's find the critical value associated with a 95% confidence interval. All right, so the critical value that's associated with a 95% confidence interval. So what this means is we have 95% of the distribution in the center. Okay, so 0.95. Okay, so this is the distribution of z, okay? And since it's a 95% confidence interval, 0.95% of the distribution is in the center. All right, and then we want to find z alpha divided by 2, right? That's the standard normal critical value that we're looking for. Of course, there's also the negative cutoff over here. Same number, just negative. Okay, well, I need to know what the area in this tail is. In both tails are actually. Okay, so the area in the center, this is 1 minus alpha. The area in the center is 1 minus alpha. So alpha must be 0.05 in this scenario, right? Because 1 minus 0.95 is 0.05. So the area that's left over in both these tails must be 0.05. And so half of the area is in both these tails, actually. Half of 0.05 is in both these tails, because you got to split it up. The entire area under the curve is 1, right? So I have to split up that 0.05. So 0.05 divided by 2 is 0.025. So there's 0.025 area here, 0.025 area here, right? We could sum these up. 0.025 is 0.95 plus 0.025 should add up to what? Okay, good. All right, so what I'm trying to figure out is what is z alpha divided by 2? What is this z right here? What is this cutoff? Well, I'm going to have to use my table. And I'm using my table. I'm going to look for, what is this value for which the area behind that value is going to be 95 plus 0.025. right? Both of these, it's going to be both these regions. So 95, so 0.95 plus 0.025 equals 0.9975, right? So this entire area that I've marked in red is 0.975. So when I go to my table, I'm going to look up inside the table for what's the z-value that has an area behind it of 0.975. All right, so let's go look that up. So we're looking inside the table for 0.975. So where the area is 0.975, there we see it right there, 0.975. Right, so the z-value that corresponds to the area being 0.975 is 1.96. All right, so there we go. This z-value equals 1.96. All right, so the critical value that's associated with a 95% confidence interval is 1.96. All right, let's do another example. Say we have to find the critical value that's associated with a 90% confidence interval this time. Okay, so 90% is in the center of a standard normal distribution. Okay, so 90%, 0.9, and this cutoff, the positive version of the cutoff, is the critical value. Right? So you can find the negative number and then just make it positive. You could do this either way. I like to just go ahead and find the positive version though. Okay, so there is the negative cutoff, which is the same number, it's just negative. All right, so let's see. So 1 minus alpha is in the center, right? So alpha then must be 0.1, right? Because 1 minus 0.9 is 0.1. So the amount of area that's left over for the tails is 0.1. We have to split that area up. So 0.1 divided by 2 is 0.05. So 0.05 is the area in each of the tails. Right? So the total area under the curve is 1. 0.05 plus 0.9 plus 0.05 is 1. Good. Okay. So right now I'm trying to find what is this cutoff here. So if I'm looking at my table, I want to look up where the area behind this number is going to be 0.9 plus 0.05. 0.9 plus 0.05, which is 0.95. Okay, so I want to look up 0.95 in the table to find this value, this z-value. All right, so let's go ahead and do that. Let's look at our table. So we're looking at the table for 0.95. All right, looks like I'm going to have to scroll down. Here we go. No, let's see. Oh, wait, here we go. Between these two numbers. So 0.9495 and 0.9505. Actually, it's exactly between these two numbers. So since 0.95 is exactly between these two numbers, we'll go ahead and take the middle number between 1.64 and 1.65. So the middle number between 1.64 and 1.65 is 1.645. So that's our critical value. So this equals 1.645. Right? So Z alpha divided by 2 is 1.645 for a 90% confidence interval. Let's do one more example. Say now we're trying to find the critical value that's associated with a 98% confidence interval. Okay, so this is distribution of Z. 0.98 is in the center. All right, that means I've left over 0.02, right? Because 1 minus 0.98 is 0.02. Right? And so I have to split up 0.02 into both tails. So 0.02 divided by 2 is 0.01. So the area here is 0.01. The area over here is 0.01. So total area under the curve is what? So let's check that. 0.01 plus 0.98 plus 0.01 equals 1. Good. Okay, so this is the negative version of the critical value, and this is the positive. All right. We want the positive. We always want the positive value. When we're talking about critical values, we're always talking about a positive number. All right. So if I go in my table, I'm going to want to look up the value for which the area behind it is, let's see, 0.98 plus 0.01, right? So 0.98 plus 0.01, which is 0.99. Okay, so I'm going to go to my table and look for 0.99. Okay, 0.99. Aha. Okay, 0.99. So let's see. So we see here 0.9898, okay, which is 0.0002 away from 0.99. And then 0.9901, which is just 0.0001 away from 0.99. So this value is closer, actually. So we're going to go ahead and take that value, the one that's closer. So the z value then will be 2.33. 2.33. Okay. So this value is 2.33. The critical value for a 98% confidence interval is 2.33.